Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are working on the year-end summative. It's question 19, which is from the Analytic geometry section. And here's the question. It starts with draw a triangle, and then it has us do all kinds of math with that triangle. So just so you know, this is going to be a pretty long bit of math we're going to have to do, so get comfortable. It starts pretty nicely. Draw a triangle with the vertices P, Q, and R. So let's do that. So here's P, negative 5, 1. Q is at negative 3, 5. And R is at 3, negative 3. So there's my vertices. So if I connect these, I will create triangle PQR. So there it is. It's not that neat, but don't worry, I'll clean it up in a second. So there's triangle PQR. That was easy. Now we need to determine the equations of the medians from each vertex of the triangle. So let's make sure we understand that a median line is a line in a triangle that does the following. So it's a line in a triangle joining a vertex to the midpoint of the opposite side. So for example, here's a triangle. It's not the triangle we're talking about. So for example, here's a vertex. Let's call it vertex A. And if I join this vertex to the midpoint of the opposite side, somewhere around here, then this line would be the median from A. Here's another vertex. Let's call it B. There's another median line because I could also draw the median from B if I joined this line to the midpoint of this side. So there's another median line. And of course, there's another one from the third vertex. So that's what a median line is. So let's do it for this triangle. And there it is, as I promised, a nice, neater version of this triangle. And so we're going to start by finding the median from P. So again, what I need is I need point P, and I need a point on QR, which is the midpoint of QR. So I'm going to call it point X, and let's start by finding where point X is. So the midpoint, capital M, of QR, which I'm now going to define as point X. So let's use the midpoint formula. Here's Q and R, and let's find the coordinates of that midpoint. So x1 plus x2 divided by 2, y1 plus y2 divided by 2. So I get negative 3 plus 3 is 0, divided by 2 is still 0. This is 5 minus 3 is 2, so the midpoint of QR, which is now our point X, has coordinates at 0, 1, and that's about where I drew it. So now we need to find the equation of the line that goes through P and X. So let me add that to our diagram. So we need to find the equation of the line that goes through P and X. So here's point P. Oops. Hold on. So here's point P. And here's point X. So now all we need to do is use those 2 points and find the equation of the line that goes through P and X. So you may already notice that it's a horizontal line, so this isn't going to take too long, but I'm going to do the math anyway just in case. To find the equation of any line, I need to know the slope, and I need to know a point on the line. So I've got 2 points on the line, and I'm going to use them to find slope. So y2 minus y1 over x2 minus x1. So y2 minus y1 over x2 minus x1. So I get a slope of 0. And again, if you look at your diagram, it's pretty sure it's a slope of 0. So my equation is y equals 0x plus b. So if I take either of the points that I know, so again, I can either take point P or point X. I'll take point X. So 1 equals 0 times 0 plus b, so b equals 1, which means the equation of this median line is y equals 1. If I wanted it in standard form, I could say y minus 1 equals 0, but I think this is okay. So that was the median from P, and now we're going to do the same thing. We're going to find the median from Q. So here's point Q. So somewhere on PR is another midpoint. So we're going to find the midpoint to PR, and let's call that Y. And so Y to find it, again, we're going to use the midpoint formula. So I need P and R. So negative 5 plus 3 divided by 2 and 1 plus negative 3 divided by 2. So here I get negative 1 and here I get negative 1. So the point that we're calling Y, the midpoint of PR, has these coordinates. And now I need to find the equation of the line that goes through Q and Y. So to start an equation, we always want to start by finding the slope. So the slope, oops, hold on, I need my pen. So the slope, and again, the only points I'm allowed to use now are the 2 points on this median line, which are Q and Y. Those are the only points I'm allowed to use. So I like highlighting them, that way my brain doesn't pick up the wrong number at the wrong time. So I need to calculate Y2 minus Y1 over X2 minus X1. So I'll do negative 1 minus 5 over negative 1 minus negative 3. So I get negative 6, negative 1 plus 2, negative 6 over 1. So I get a slope of, oh wait, hold on, let me do my math correctly. Negative 1 plus 3 is actually 2. So I get a slope of negative 3. So right now, this is what I know about that median line. And now I need to find this B value. And to do that, we take either of the points that we know. I'll take Q and sub it in for X and Y. So Q is negative 3, 5. So subbing it in. So I've got, 5 equals 9 plus B. So B is negative 4. So the equation of this median line has a slope of negative 3 and a y-intercept of negative 4. So there's the median from point Q. And again, if I look on my graph, I can see it's negative and so on. So it looks pretty good. So one more to go. Now I need to find the equation of the median from R. So here's R. It's going to be a line that connects R to some midpoint over here. Let's call that Z. So I need to start by finding that midpoint, the midpoint of PQ, which we're calling Z. So negative 5 plus negative 3 divided by 2, and 1 plus 5 divided by 2. So doing the math, negative 8 divided by 2, and 6 divided by 2. So Z is the point negative 4, 3, looks about right. So now I need to think about the line that connects Z to R. So the only points I'm allowed to use for this line are the points R and Z. So let's go ahead and find the equation of it, and as always, we want to start by finding the slope. So the slope formula, y2 minus y1 over x2 minus x1, so 3 minus negative 3 and negative 4 minus 3. So I get 3 minus negative 3 is 6. Negative 4 minus 3 is negative 7. And reducing that fraction means putting the negative sign in the appropriate place. So there's the slope. So far, this line has this equation. Oops. Hold on. Try that a little neater. And so that's what I know, the slope. And now I need to find the y-intercept. So I'm going to take one of the points that I know. So I will take point R, 3 and negative 3. So y is negative 3. X is positive 3. And now I just need to solve for b. So negative 3 equals negative 18 over 7. I'm going to multiply everything by 7 to get rid of that fraction. So negative 21 equals negative 18 plus 7b. Add 18, negative 3 equals 7b, and divide by 7. So if I divide by 7, I end up with a b value of negative 3 over 7. So now I know that this equation has a slope of negative 6 over 7 and a starting value, or y-intercept, of negative 3 over 7. So that's the equation of the median line from R. So just to summarize what we just did, I found the median from P. So here it is. We found the midpoint, I called it X, there's the median line, and there's the equation of that line. We found the median from Q, so we found the midpoint of PR, called it Y, and the equation of this line is right here. And then the median from R looks like this. There's a vertex R, there's the midpoint of the opposite side, and there's that median line. Now you'll notice that all of those median lines meet at the same point. And that's what the next part of this question is about. It says determine the coordinates of the centroid. And that's the point of intersection of these medians. So here, again, visually, is where those median lines intersect. It's a point called the centroid, and that's always where the median lines of a triangle meet at something called the centroid. And our goal now is to find the coordinates of that point. So I'm going to take, here's my three equations. Oops, they hid. Let me pull them back here. So there's my three equations. So I have three equations, and I need to find this point. So I'm only going to take two of those equations. I'll take the first two because this one's ugly. I'm going to take two of the equations, and I'm going to find where they intersect. So I'm going to take the first equation here and the second equation here. I'm going to find where they intersect, and then just check my math by evaluating it and making sure it works in the third equation. So I'm going to take, again, these two equations and find where they intersect. So equation 1 and equation 2. And we can solve using either elimination or substitution. This time I'll do substitution. So from equation 2, I know that y equals negative 3x minus 4. And what I'm going to do is I'm going to sub in equation 1. And what that means is instead of y, I'm going to sub in what y equals. And in this case, y equals 1. So 1 equals negative 3x minus 4, and now I can solve for x. So add 4 to both sides and divide by negative 3, and I get an x value of negative 5 over 3 equals x. And of course, we already know that the y value is right here, y equals 1. So the centroid is at negative 5 over 3, comma 1. So I used equation 1 and 2 to find this centroid. I'm just visualizing here on my graph that it makes sense. So negative 5 over 3 is like negative 1.7 and up 1, so it's pretty reasonable. But what I want to do is I want to make sure that that's the centroid. And I'm going to do that by testing the centroid I found from equation 1 and 2. I'm going to test and make sure that it's also on this third equation. So I'm going to use a left side, right side table check. Left side and right side. So the left side of the equation is y. And the right side of the equation is negative 6 over 7x minus 3 over 7. And I'm going to sub in this x and this y and see if I get a valid left side, right side balance. So y was 1, that was easy, and x was negative 5 over 3. So on the left, 1, and then I have a bunch of lovely stuff to do over here. So negative 6 times negative 5 is 30, so I get 30 over 21 minus 3 over 7. I'm going to get a common denominator. So 30 over 21, I can easily make this into denominator 21 if I multiply by 3. So if I multiply the 7 by 3, I also have to multiply the 3 by 3. So I get 9 over 21, which is equivalent to 3 over 7. And now that both denominators are 21, 30 subtract 9 is 21. And 21 divided by 21 is 1. So left side equals right side. So on the left side, I have a 1. On the right side, I have a 1. And therefore, negative 5 over 3, comma 1 is on equation 3. So I didn't really have to do this. I just wanted to verify that my math was correct because I used two of the equations to find the centroid, and now I'm just checking to make sure. And yes, that is in fact the centroid. So again, determine the coordinates of the centroid, the point of intersection, and I found it. It's right here. And I checked that I did my math right. And then finally, it says show that the distance from the centroid to each vertex is as long as the distance from the centroid to the midpoint of the opposite side. Good. Okay, I just checked. I am missing a word, a very important word. It should be show that the distance from the centroid to each vertex is twice as long as the distance from the centroid to the midpoint of the opposite side. So in other words, if we visualize what's going on here, they want me to show that the distance from the vertex, like P, to the centroid, that this distance here is twice as much as the distance from C to X. So that's what we're going to do. We're going to find the distance from P to C, and we're going to compare it to the distance from X to C. And we're supposed to show that this one is twice as long as this one. So we're going to use the distance formula. So from P to C, so x2 minus, x1 is minus 5 squared plus y2 minus y1. So that's nice. This is not so nice. So what do we get? So here we get negative 5 over 3 plus 5 squared plus 0 squared. So we don't really need that anymore. So negative 5 over 3 plus, now it says plus 5, but I need to add them, so I got a common denominator of 3. Oops. Oops. I don't know if you saw that. So I changed this 5 into 15 over 3 so that I have a common denominator, and I'm not going to write plus 0 squared anymore because that's just a waste of ink. So negative 5 over 3 plus 15 over 3 is 10 over 3 squared. And of course, the fact that I'm squaring and square rooting, so if I'm squaring something and I'm square rooting something, those two acts just cancel each other out. So my answer is 10 over 3, and as a decimal, that's about 3.33. So that's the distance from P to C. Now I need to find the distance from X to C and compare it. So from X to C, let's put that here. So from X to C, again, square root formula. So y2 minus y1 squared plus x2 minus x1 squared. So doing this math, 1 minus 1, oh, this is going to work out kind of nice. Very little math to do over here. So I end up with the square root of negative 5 over 3 squared. And again, squaring and square rooting cancel themselves out, except for be careful, because if I square a negative, I get a positive, and square rooting a positive gives me a positive. So I actually get 5 over 3. And in my calculator, 5 divided by 3 is about 1.67. And now if you compare my two answers, you can clearly see, or hopefully clearly see, that 10 over 3 is twice as big as 5 over 3. Or if you wanted to on your calculators, you could confirm that 3.33 is pretty much double 1.67. So that was just for the median line through P and X. It says show that the distance from the centroid from each vertex is twice as long. So I'm going to have to do the same thing from Q, the midpoint from Q, sorry, the median from Q and the median from R. So it's basically the same process. So instead of actually going through all the steps with you, I'm just going to show it to you, and you can press pause if you want. But again, here's what I'm doing. I need to show that the distance here from Q to C is twice the distance as from C to Y. It looks like it, but let's look at the math. So here's the math, super neat, because I typed it, that shows the distance from Q to C, right here. It's about 4.2. And the distance from Y to C is right here, and that's about 2.1. And therefore, the distance from the vertex is twice as much as the distance from the midpoint. And again, we have to do it one more time. This time for the vertex R, we want to show that distance from R to C is twice as much as from Z to C. So again, using the distance formula, here's my answer. And again, you can see when I do the decimal calculations that the distance from the vertex to the centroid is twice as much as the distance from the midpoint to the centroid. Okay, that was a lot. It would have been a lot longer if I had to write that all out. Okay, so that was that question. Thanks for watching.